Hello everyone, my name is Parasangal and in today's video I am going to talk about switch and its methods and why do we use it in a network. Switch is a layer 2 device. It functions at the data link layer of the OSI model and its main job is to send the Ethernet frame or data based on the destination MAC address, and it stores all the MAC addresses in the MAC table. Switch work on the full duplex technology, means meaning uh, it allows two-way communication between devices, unlike a hub, a dumb device that work on half duplex, means can send and receive data one at a time. Switches has multiple ports, 24 ports, 48 ports, and even 12 ports. Switch supports VLAN, so we can logically separate the devices in a network, and switches run HTTP protocol in the background to protect the switching from the loops, and that is how a switch work. It provides a reliable communication in a network and connects the end devices like PC servers and laptops, smartphones, and all of those. Without a switch, we cannot create a lane network because it provides multiple ports to connect, and also uh, it does understand all the devices by by sending and receiving MAC address, and all of those things is being done with switch, and we can do a lot of things in switch. Switch supports many protocols as well. So how does switch works? So here is a diagram that you can see a host A and host B connected to a switch through fast Ethernet cables, and host C connected through a fast Ethernet cable. Three of the uh, PCs are connected to the switch, and here so how does a switch work? The first thing is that if a switch has the entry of the MAC address of the device, then he forwards the frames to the destination. In the second case, if switch don't know the destination MAC address of a uh, of the PC, and it has no entry in his CAM table, content addressable memory or a MAC address, then he generates a ARP request, which is a address resolution protocol, and it is the first ARP request generate, and it broadcast that request to all the devices in a lane. Then the PC who has the MAC address and attached to it, who knows that this frame is arrived to me, and that destination PC is going to reply with its MAC address and going to tell, hey, uh, I am this one and this is my MAC address. So, and after that, switch again forward the frame to the source, and going to store the MAC address of the destination. So this is by the unicast message, and this is the whole process from when the destination is unknown, which generates a ARP request in the broadcast to all the devices in the network, and when the reply come back from the device, it is store the MAC address of a particular device and store in his MAC table. To be summarized, it's like that. So after that, any communication is being take process. You can see if host C, if host C wants to communicate again to host A, and if switch has an entry of the MAC address of a host A in his MAC table, then he is going to send a unicast message and to the host A directly. So switch also updates its MAC entry time by time. So it does not keep all of the entries available, all of the entries of all the time. So if a connection is established or a PC connected to switch plugs out, disconnect from the switch, then the MAC address is being removed from the switches MAC table. So if the destination is known, it sends and receives the MAC address and makes the communication possible between the end devices. There is also a thing that aging time. Aging time is known as that when see like going to give you an example. So in a corporate environment, when 20 users are coming in day shift and they are connected to a switch. Okay, they are working on a switch, and switch has all the MAC address entries of those devices. And in a night shift, if 20 users, new 20 users comes again and plugged into that switch, the switch does not keep the entry of the old the PCs or users that came in the day shift. So it flush out those entries, and that's how it operates. Because if it will keep all the if a switch will keep the older entries in its MAC table, uh, it can like it is a MAC. It is known as like the bird the packet of the frame will not reach to the destination properly, and the frame flooding will start. And that's why we do switching, and that's why we do switching. And how it prevents loops, and it prevents that a frame doesn't reach to the wrong destination. So MAC address table is being refreshed um, time by time. So that's how a switch operates. Switching mechanism. Switching use three mechanism, and it is a Ethernet frame mechanism. Like how does it process the operation of sending frame to the destination? First is store and forward method. In this switching method, the frame has to be entirely come before making a forward decision. So entire frame is received, then send it to the destination MAC address. Simple. And it's work at the access layer, or and like access layer or end devices connected. Cut through method. Ethernet switch that uses cut through switching can make forwarding decision as soon as the first couple of bytes are received. And this method is quite fast than store and forward, but it is less reliable because only first frames are received. It does not do any security check, or it does not run any CRC for it. In the fragment free uh, switch, in this mode, when in a fragment free method, the first 64 bytes of the frame are received, means a MAC address is received. And as soon as the MAC address is received, uh, and the frame is like processed or processed to the destination. So, and it is the old method. Nowadays we do not use fragment free method in the switching mechanism. And yeah, store and forward and cut and through are quite popular and widely used in the network. Switch floods three types of Ethernet pin. As I discussed below, broadcast frames. When the destination MAC address is unknown, it send all Fs. You can see one destined Ethernet broadcast address, all Fs. So if you will check a packet, and when sending to um, a destination PC where you don't know about it and you haven't make any communication, you will check the broadcast addresses are all Fs. Means the broadcast address is unknown till now. Multicast frames, one destined to MAC address that starts with bits 110, and unicast ones that have destination MAC address that is not in the MAC. So these are things that I've discussed with you. This is a overview about switch and switching. Thank you for everyone.